So, welcome. This is the first of 3 workshops being given by Daniel Bolajan. He will be looking at StyleGAN, CycleGANs, and Pix2Pix. Daniel is a wonderful colleague from Digital Futures. He was instrumental in making Digital Futures World work over the summer. He also was a former colleague at FIU, where he was a visiting professor 2 years ago. Now he is down the road at FAU, at Florida Atlantic University in Fort Lauderdale, where we remain in close contact. Daniel is collaborating still with Wolf-Prix. Daniel is from Romania. Years ago, I gave a lecture in Iomincu, the leading school in Romania. I'm not quite sure what I said, but it seems to have influenced Daniel's career. And he's become one of the great computational experts. He went from Iomincu to Angavanta, the famous school in Vienna, where Zaha and others were teaching on with Wolf-Prix. And now he's in Fort Lauderdale. It's a great honor to have Daniel here. I've just completed my manuscript on a book on AI, and I must say Daniel is one of the leading figures, and I don't think we could have anyone better to be leading this particular workshop. So thank you, Daniel. Just to say to everyone that if you haven't put your name and email address on the Google Docs in the chat, please do so, because we'll need to do that to get the various downloads. Okay, Daniel, over to you.
Thank you. Do I have permission to share?
Sure.
Let's see. Yes. Okay. Okay. Are you able to see the screen? All good?
Yep.
All right. All right. So this workshop, I'm going to try to focus on this workshop when it comes to. I'm trying to focus on the workshop in a way that is very addressed to architects, let's say. I'll try in a way to steer away from very technical aspects, because I understand that many of you don't have a background in computer science. So because of that, many concepts, I'll try to introduce them in a very plain, let's say, language, so that we are not making things even more complicated. So the strategy here will be over the next weeks, like 3 weeks. First week, which is today, I'm going to try to mostly go over setting things up so that we are able to start to work with neural networks. I'm going to also show some ideas, and I'm going to give now a presentation where I'm going to show some ideas about how GANs or different AIs are used. And mostly I try to focus the presentation on my personal work, although I had to give a few examples from other researchers. But mostly I just wanted to show you like how we try to implement AI in Kopino-Blau, and also some parts of my research in AI. So mostly we are going to deal with a class of deep neural networks called GANs, generative adversarial networks. And I'm going to explain those just in a bit. Then the following week, or next Saturday, we are going to look over how we operate Pix2Pix network, how we operate CycleGAN, how we deal with data augmentation, how we set up data set, and so on. And then the last week, we are going to focus on StyleGAN, which, as you'll see, it's quite, or I think is the most advanced in a way network when it comes to image synthesis. So let's continue then, and I'm going to try to just address a few basic topics and try to just give you some ground, in a way, some solid ground to understand the concepts at least. We are not going to go in super technical details, because I think that's not the purpose here, but I'm going to try to at least introduce some concepts and make sure that we all understand those concepts. So what is an artificial neural network? So we can define in a way artificial neural network, or we can say that artificial neurons simulate the basic functions of biological neurons: input, processing, output, and passing information to other neurons. Each input is given a weight to signify how important it is compared to other inputs. So it's very similar than with the way that also we as humans operate. So we have some input information that has certain relevancy or different importance. And then we have processing unit. Let's say you have the brain that starts to weight that information, and then you have a sort of output. Yeah. So I'm going to give a few examples how that actually applies in the way that we as humans operate and also networks operate. So then we can say that an artificial neural network is a simple mathematical model of the brain, which is used to process nonlinear relation between input and outputs in parallel, like a human brain does every second. Yeah. So a neural network then tries to mimic, in a way, the same kind of process that happens also in the brain. You have an input information, you have processing of that information, and then you have an output. For example, if we talk about classification, as a human, you'll have a input, like a visual input of an object, and then your brain will work as a classifier and determine what object is that. Is that a bottle? Is that a can? Or is that a microphone? Or is it a phone? Or what it is? Yeah. So in a very similar way, then also networks operate in a very similar way. You have input layers, which mostly have the information that's going to be input in the network. Then you have in between a hidden one hidden layer or multiple, depending now on the structure of the network. And then you have an output layer. Yeah. So in the case of a network, you have input information, like let's say an image of an object. You have hidden layers that try to understand what that image is, and then output layer answer what object that is. Yeah. So it's very similar with the way that also human brain works. Yeah. So this is a very basic, in a way, network. And let's say that this is a classifier network, a network that's capable of looking at a data set, a set of examples, and is able to give a sort of classification. So that could be a classification when it comes to images, like it's looking at some images and it's able to say what kind of objects or figures humans are into that image. Or it could be also something else, like pure numerical values, where you're looking, let's say, at a data set of prices, real estate prices, and then you try to classify and to determine in a way what type of property that is based on the price, for example. Yeah. So if you let's imagine that we try to create a classifier network, yeah, a network that is capable to classify, like to look at a set of images, and it's able to predict which image is, let's say, Sagrada Familia and which image is Notre Dame. So the way that this will work is you give this network a lot of pictures of Sagrada and Notre Dame, and then you present it with an image of Sagrada, and the network would output a number from 0 to 1, for example, yeah, where 0 represents Sagrada and 1 represents Notre Dame images. So you input a Sagrada image and it outputs 1, and you say, no, that's not right, yeah. So it should be 0, not 1. And then you keep training this network until eventually the network can tell the difference, yeah. So somehow what we can say is that somehow inside the network was capable to form some model of what Sagrada images are and what Notre Dame images are, as far as images is concerned, yeah. So, but that model, you can say that model then it's able only to classify things, yeah. You cannot ask that model, that classifying model, you cannot ask it, draw for me a new Sagrada Familia image, or draw for me a new Notre Dame image, or draw for me an image that I never seen before. So it doesn't know how to do that. That is just able to recognize this image of Sagrada, and I'm going to give a value of 1. If it's an image of Notre Dame, I'm going to give a value of 0. Yeah, so like that is just creating classification. But quite often, you want to have a model capable of generating new samples or new images, let's say. So you give it an amount of images of particular samples distribution, and you want it to give you more samples that are from the same distribution. So when I'm saying distribution, I'm mostly talking about if I'm giving images of Sagrada Familia representing Sagrada Familia, then if I input those images to the network after the network is learning, the expectation will be that the network is able to output or create completely new images that are from the same Sagrada, in a way, Familia distribution. Yeah. So what that means is that the network has to learn somehow the underlying structure of what you give in. Yeah? So if I give a set of images of Sagrada Familia, somehow the network has to learn the underlying structure of those images and the composition and so on. So if you think about it, that's a very tricky thing, because if you think about it, for a human, although you know how Sagrada Familia looks like, it's very hard for you to generate a drawing of that particular building. Yeah, more than that, to draw completely interiors, yeah, of Sagrada Familia with the same language. So it's a very complex process. It's very similar. This problem is very similar with that scene from I, Robot, where Will Smith is interrogating the robot, and Will Smith, in a way, is making this comment that the robot cannot create, cannot sing, cannot compose a opera or something, and the robot is it's answering back, but do you? And I think it's the same thing also here. It's like the network in the end has this kind of super challenging task of learning Sagrada Familia images and then generating new ones. But if you think about the task itself, it's extremely complex even for us humans. Yeah, it's very hard for us to really create a completely new novel output of that Sagrada Familia while still representing or still respecting, let's say, the compositional rules described in those kind of images. So the type of or the family of neural networks that we are going to work with is called generative adversarial networks, and it's a type of or a class of networks that allows, in a way, allows a network to learn the representation of a set of input data and then generate completely new data based on that. So, for example, you can input completely, or you can input a set of images of Sagrada or other buildings, and then the network, once it's learning, it's able to actually create completely new images of that specific building that represents the building characteristics, compositions, and so on. So yeah, in that sense, then the generative adversarial networks are tackling the problem of if you want to have a network that's able to create completely new samples. So the interesting thing about generative adversarial network is that you actually have two networks. You have one that is learning to generate images, and you have a second network that is learning to tell the difference between the generated images and examples of real images. So I'm just going to go slightly now over a few examples of GANs before I go more in depth here. So this is the progression of GANs from 2014, when they were first introduced by a young fellow, till now today. Yeah. So you see, like, there is a very it has a very steep, in a way, progress, let's say, curve. Yeah, it's really moving very fast, and it's learning very fast at the moment. And the models that are out there, they keep on improving. Yeah, the networks that are being further developed by researchers, they keep on getting better and better and better. So in 2014, you see the level of resolution and detail that a network was capable to generate versus now 2020, yeah, where the latest StyleGAN 2 network was published by NVIDIA. Now, of course, all this discussion is not just a matter of coding and matter of researchers developing neural networks. It's also a question of the computational power that we start to have access to after 2014 on, yeah, with a lot of like NVIDIA graphic cards and so on. So I'm just going to go over. Are you able to hear the music here, the sound, or do I have to share somehow the screen differently?
I think on the screen share, or is it that?
Okay, I'm going to start a new screen share, show computer sound. Okay.
Is it that? I'm not sure. Let's try and work out.
Okay, so what about now?
Yes.
Okay. So what you're looking at here, you're looking at a network that was able to learn features of human face at different levels, yeah? Meaning was able to look at the shape of the face and the structure of the face and was able to learn that, yeah? And then was able to learn other facial features and more detailed features, yeah? So that's why in a way you see this kind of network outputting this kind of images and these kind of translations. And the translations are so realistic and so flawless in a way, has to do mostly with that ability of the network to learn across multiple levels, yeah. And here, this is what we describe by core style, middle style, and fine style. So you see when you are in the core style, mostly you are changing the shape, the overall shape. Then the middle styles, they address slightly other features, yeah. So in this sense, you can say that what you have here, you have a network that actually was able to understand and to learn the underlying, in a way, compositional rules and semantics of a set of images of faces, yeah. Yeah, so I'm just going to slightly skip over because it's quite long. But here, there are just different ways how you can control them and manipulate, in a way, certain features. So similar technologies are also applied in deepfakes.
Is anything more sad and lame?
Just a second.
Contemptible, beneath disdain.
In short, provoking of disgust than being an impressionist.
A third-rate, even fourth-rate skill. The definition of cheap thrill. Like watching farm equipment rust is watching an impressionist. Relic from a distant day that long since should have died away. Dishonorably mentioned is the pitiful impressionist. Weird and slightly ostentatious, tired debris from old Las Vegas.
Whose former fans have long dismissed allegiance to impressionists.
How many opportunities passed up and wasted because he's hell-bound to follow what he must? Pity the poor impressionist.
Doomed to live in abject failure, dogged by his own echolalia.
Better to crumble into dust than wind up an impressionist. His borrowed voices can't deflect a life of well-deserved neglect.
His name's on simply no one's lips. Forgotten, vain impressionist. That sound, did anybody moan? That creature with the microphone
Is last on everybody's list. Forgettable impressionist.
When Peter, at that shiny gate, condemns those souls who imitate.
You will but shake a heavenly fist and curse condemned impressionists.
But till that time, we'll tolerate the good-for-nothing reprobate.
And hide the truth that we're just pissed that we can't be impressionists. Oh.
Yeah, so these are some really amazing, like state-of-the-art, like AI, and where generative adversarial networks are at the moment. So initially, they were introduced by Jan Goodfellow, a researcher in computer science, and he came up with this idea. What if you can turn off your mics, would be great.
All with clinically proven ingredients to clear skin and dermatologist tested to be gentle. Subscribe today. It's free at proactive.com.
Can somebody turn off the mics? The mic?
You can probably mute her or him.
Okay. Do we have a moderator, somebody that can take care of that part?
I believe they muted themselves already.
Okay. All right, so Jan Goodfellow, he came up with this idea while arguing with some friends in the bar. And the thing, in a way, that clicked there for him was this idea of having the discriminator network, which is the network that, in a way, identifies or tries to classify if certain images are real or fake or synthetic. So the idea of having the discriminator continually learning at the same time that the generator is learning. Yeah. So in this, the concept here, or the idea of the GANs, is not only that you have a network capable of learning the underlying structure of something, but you also have another network that is able to classify and identify if what the first network learned is correct or not. Yeah. So in this way, what you end up with, you end up in a sort of adversarial game where, while one network is learning, the other one is also forced to learn and to become better at recognizing synthetic images or samples from real ones. Yeah. Okay, so next slide. So it's this kind of idea of adversarial learning, yeah. Catch me if you can. Like this kind of idea of you have somebody who, a forger who tries to forge money, let's say, and then you have an expert that has to be able to detect if those money are true or are real or not. So you can imagine almost like, even if we, let's say that we make an analogy as painting, a forger that tries to paint Mona Lisa, let's say, and you have an expert, an art critic that is able to identify, or it's able to tell in a way what painting is Mona Lisa or not. But let's imagine that at the beginning, both the forger and also the critique, they are not very, very smart. They are not very, their expertise is not that good. So let's imagine the scenario. So you have somebody that starts to create a fake Mona Lisa painting, but because the critique is not very good at that skill to recognize Mona Lisa, what will happen? The forger will keep on creating new fake paintings of Mona Lisa until the critique is able to learn and to recognize certain things. So let's say that the forger starts to use a certain paintbrush, and he's painting with that brush, and it has a certain texture that is not the same with the one from the original Mona Lisa painting. But if the critic is not able to recognize those kind of like brush patterns, then it's not going to be able to recognize the fake from the real one. Once the critic is able to, the art critic is able to recognize that there is a certain specific texture, brush texture that the original Mona Lisa has, once he does that, then he can tell the difference and can spot in a way that that painting is fake or not. Yeah. So once the critic is able to learn that aspect, now the forger is forced in a way to learn new tricks, how to make the forgery even better. Yeah. So now instead of, let's say, looking at the brush, maybe the forger starts to look at other aspects of texture. Yeah. And then the forger maybe starts to learn those textures, and they become very, very, very convincing until a certain point where the art critic, let's say, fails to recognize those, as being fake. So if you continue this game in a way like that, you see that what's happening is both the forger and also the expert, they are keep on learning based on this kind of adversarial, in a way, process. Yeah. So adversarial learning is a way of learning machine, or a way of learning machines or machine learning systems, which involves focusing on the system weakness. Yeah. So when we talk about adversarial learning, what we are doing, we have a sort of system that focuses only on the weakness of a certain system. So let's say if you are teaching somebody to recognize numbers, and let's say that after a period, you realize that that person can recognize with high accuracy, something like, let's say, 70% of the numbers. Yeah, it's able to recognize 70% of the numbers, but has issues recognizing or making the difference between 1 and 7. So if you think about it, what you will probably do, you will not continue to train or to ask that person to keep on learning the other numbers, because you already know that that person is quite good with the rest of the numbers beside 1 and 7. Yeah. So what you'll do there, you'll just stop and you'll start focusing only on 1 and 7, because this is an issue for that person. And what you're going to try to do, you're going to try to keep on showing that person different examples of 1 and 7 until that person starts to recognize correctly 1 and a 7. Yeah. Until, in a way, this way of recognizing these numbers, it's getting very close to being able to recognize the other numbers. So in this sense, what you are doing, you are focusing the training, let's say, on the area on which that particular person is failing. Yeah. So you're focusing your entire teaching and training of that person only where there is an issue. Yeah. So similarly then in generative adversarial networks, when it comes to the way that they are constructed, their architecture, you have one network that is called discriminator. So the discriminator network, it's basically just a classifier network, yeah, like the one I mentioned in the previous example. So I'm going to give you an image of Sagrada, let's say, and if the image is Sagrada, it has to be 1. If it's Notre Dame, it has to be 0, yeah. And then this discriminator is looking at those images, and when it's seeing an image of Sagrada, it's going to say, okay, this is 1. Looking at the image of Notre Dame, it's going to say 0, yeah? So in a similar way then, the discriminator in a GAN network is going to look at real versus fake images, and it's going to output a number, yeah? So you give in an image, and it outputs a number between 0 and 1, yeah? Is this real Sagrada image, or it's a fake one, or other buildings, yeah? And then a generative adversarial network usually has also a generator, yeah? So the generator gets as input initially, depending now on the type of network. Right now, I'm just showing you a very general, in a way, generative adversarial network, like the main concept behind it, because the other network like StyleGAN and Pix2Pix and CycleGAN, they don't necessarily use only random noise, yeah? So in this instance, the network that I'm showing here, a very basic GAN network. So you have the generator that gets as input some random noise. So from that, it generates an image, and the idea is supposed to look. The idea is that that image that is creating out of the noise, the idea is that that image has to look somehow like an image of Sagrada or what other data set you work with, yeah? So it's very similar this with the example that I was giving with Mona Lisa painting. It's almost like this generator. It's a very, very, not very talented, let's say. So first it's just going to create something super, super pixelated, yeah? And then you have a discriminator that says, I'm looking at these two images, an image of Mona Lisa, and I'm looking at this image generated. So one image is very pixelated, this image is Mona Lisa. So I see that this one is fake, the one that is pixelated. So the generator is forced then, yeah, to keep on, in a way, iterating different variations, let's say, of that kind of noise and images that is generating until it reaches that level where it starts to generate images that are more like Mona Lisa or other kind of data set that you input. So we can say that generative algorithms, which are mostly the generator network, instead of predicting a label given certain features, they attempt to predict features given a certain label. So when I'm saying label, mostly I'm referring to a way to inform a network what something is. Yeah, for example, if you have an image of a cat, you can in a way create a sort of label, almost like a contour around that cat, and specify if that contour is red, for example, that's always going to be a cat. Yeah, so like that, in a way, the network is able to always look at something that has a red color and recognize it as being a cat. Yeah, so that, for example, will be an idea of a label. So when it comes to discriminative algorithms, they try to classify input data. Given the features of an instance of data, they predict a label or category to which that data belongs. Yeah. So for example, here what we are referring to, if you have the generator generating images of Mona Lisa or Sagrada Familia, the discriminator has to be able to tell that that's a Sagrada Familia or that's a Mona Lisa painting. Yeah. So that's what is meant by they try to predict a label or category to which that data belongs to in the end. So the way we do this with generative adversarial network is this architecture whereby you have two networks playing this kind of adversarial game. Because in the end, you can say that these two networks are fighting for one number. Like which network it's closer in a way to so the generator in a way tries to create images that are closer to real images, and this discriminator tries to predict or to identify images as much as possible as being fake or real. Yeah, so it's a sort of number that they are fighting against, one that is trying to increase the accuracy of creating real looking images, and the other one a value or accuracy in terms of predicting the correct fake or real image. Yeah. So one of them wants the number to be higher and one of them wants the number to be lower. Yeah. So for example, the generator wants to have the number higher so that more the images are more accurate, and the discriminator wants to have the rate of error, like missing to identify correct images, wants to have that error as low as possible. Yeah. And what that number exactly, or what that number actually is the error rate of the discriminator. So like I was saying, you know, the discriminator wants a lower rate while the generator wants a higher error rate, yeah. So in this case, the discriminator job is to look at an image which could have or could come from the original data set, yeah. So here you see, let's say that this is our training set, yeah. We have a collection of images of, in this case, Sagrada Familia. So the discriminator is going to look at that training set as a reference, yeah. So it's trying to look then, like I was saying, the discriminator job then is to look at an image which could have come from the original data set, or it could have come from the generator, yeah. So here you see you have the network, the discriminator network, looking also at the training sets and also at the fake images created by the generator. And its job is to really tell which one is real and which one is fake. And it's going to output then a sort of a number ranging from 0 to 1, yeah. If this image is really real, it's going to be 1, yeah. If it's 0, then it's going to be considered 100% being fake, yeah. So the closer than to 1 the number is, then the more likely the image is real. Okay, so the process, what's happening here is that the generator gets fed as its input some random noise, and it then generates an image from that noise, yeah? And its training is pretty much the reverse of what the discriminator says about the image, yeah? So if the discriminator says that this is a fake image, then the generator knows to go in the other direction in a way and improve the image, yeah? So if the generator and if it generates, let's say, an image that the discriminator can immediately say that it's a fake, it gets a negative reward in a way. So if it generates an image that the discriminator can tell that it's fake, then that's really good, yeah, and it's then getting a sort of positive reward. So you train these two networks in a cycle. You give the discriminator a real image, get its output, that you generate a fake image, and give the discriminator that, yeah. So you always have this kind of cycle. The generator generates an image, the image goes to the discriminator checks in a way if that image is real or not, yeah, and then gets back in a way a feedback, like a value. So you might wonder, but this generator cannot just get this kind of feedback from the discriminator, like just a value, just 0 and 1, because how can it tell that it's moving in the right direction, that the generator it's improving in the right direction, yeah? Because like I was saying, initially the generator is just getting some noise as input, and then out of that noise tries to create some image. So how will the generator know that I'm moving in the correct direction or not? So the generator gets actually help, because if you set up the network right, you can use the gradient of the discriminator to train the generator. So what we have here, we are using something called a gradient descendant. And if you think about it, it's really like this scenario where you want to go down the hill. Let's say you're on top of the mountain and you want to go down the hill. It's very, you want to go down in a valley, let's say, where the village is. And it's very foggy, let's say, yeah. So the visibility is very restricted for you. So you cannot really see the village. The only thing that you can see, you just see a few steps ahead of you, yeah. So then what you'll do is you'll always, in a way, search that kind of slope that goes in a certain direction, yeah. So you keep on following that in a way, that slope, and that will guide you more likely towards the village. Yeah. So the same happens also here. It's in a way you use this kind of gradient descent, and that helps the network to be directed in the correct direction of learning. Yeah. So it's not only getting 0 and 1 as value from the discriminator, but it's getting this kind of gradient that suggests in a way which is the correct direction in which to move to generate more and more and more realistic images. Yeah, so this is an analogy that was explained also at the beginning. Yeah, so this idea of you have random inputs, then you have the generator, which is the forger that looks at that random input and tries to figure out how to create money out of it. Yeah, and then you have an enforcer that looks at those fake money in a way and defines or decides if those are fake or real money. Yeah. And if the enforcer it's fooled by it, then that the generator will just speed on or keep on creating those fake monies until the enforcer, in a way, it's able to recognize the real money. Yeah. So we can say that. I think I'm missing a few slides. Just a second. I think I'm missing. No, that's fine. Okay, so the first network that we are going to operate with, and one of the first networks that showed really promising results from this GAN family was Pix2Pix. And what Pix2Pix is, it's a network that learns mapping between pairs of images, which is a process called, or it's a supervised process, yeah? A supervised learning process. I'm just going to explain that in a second. And then we are going to also work with the CycleGAN, which learns mapping between collections of unpaired images, which it's also a supervised process. And then we have also StyleGAN, the one that I showed the video of, which is mostly a realistic image generator, which is a process called unsupervised. So when we say that we have a supervised learning process, we refer to a process in which we specify clear labels of what exactly the network has to learn. Yeah, and I'm going to show you just in a second examples what that is in Pix2Pix, for example. So in this case, you have an example from Stanislas Chalo that was looking at the relation between building outline and its internal organization. And you might wonder how exactly this was trained, if this was a supervised or unsupervised learning. Was the network able to learn by itself all this information, or it needed some assistance from a human agent? So in this case, the process, it's something like this. So on the left side, you have labels, or you have a sort of input, which is, let's say, the outline of the building. And then on the other side, you have the labels identifying different rooms, divisions in a way inside. Yeah. So then the network, you're instructing the network to look at those two images, which are perfectly matching if you're looking at it. Yeah. So this outline, it's really matching exactly this. Yeah. And the windows here and here, they are completely matching. Yeah. So that's called a paired data set. Yeah. And it's a supervised process in which you are telling a network to look at this outline and this figure and interpret that figure in this way. Yeah. So you keep on showing the network like thousands of examples like this, yeah, like building or interior organization based on the outline of the building. And the network will then start to learn, yeah, to learn what's the relation between the outline and the interior organization. So in this instance, then this is a process, it's a supervised learning process, yeah, because you as a designer or you as a human agent, you are literally giving in a way the network exactly what to learn and how to interpret certain things. Yeah, you're explicitly telling, like, you look at this and you have to interpret this outline as this, while this outline you have to interpret it like this. Yeah, after training, then you have the network. You have this kind of changing, let's say, outlines, and the network then gives predictions for those changing outlines. Okay, so another network that we are going to work with, and I start to introduce it here, is the CycleGAN network. So the CycleGAN network, it's a more complex network, and most of these networks and developments you'll see, they have to do with certain issues and problems that they try to solve. And personally, this will be where I want to have architects working with AI, not only just applying AI that's out there, yeah? Because here you'll see these are like certain computer or computer vision problems that were addressed by researchers, and that's how you ended from Pix2Pix to CycleGAN and then to StyleGAN, yeah? There are certain problems that all these networks try to address when it comes to image translations, yeah? So in this case, CycleGAN, what CycleGAN does, and what's the idea behind it, is that, so imagine that you have a network and a Pix2Pix network, or a normal network that tries to predict numbers and tries to generate numbers, yeah? So you input data set of a lot of numbers, images of numbers, and the network, let's say, it learns some representation about those numbers, and then it starts to output an image of a number, yeah? And the discriminator starts to look at those images and say if those are real or fake, yeah? But in this process, what could happen is that it could happen that the generator, the network that generates new samples and new images, it could happen that that network becomes lazy. Lazy in the sense of you have nine numbers or 10 numbers, let's say, because you start from 0. So you have 10 numbers, and the network, instead of, in a way, creating new numbers, the network, let's say, starts to output constantly just number 8. Yeah. So what's happening then is the discriminator will look at that number 8 and will say, this is correct. Yeah, this is a number 8. And then the generator will go back in the next cycle, will generate a new image of number 8, and the discriminator is going to say that's a real image of number 8, yeah? And you're going to continue doing the same thing all over again, yeah? So this is called a mode collapse in our networks. So what happens there is that the generator, it doesn't learn anymore, yeah? It's not capable to learn anymore. It's keep on repeating the same output, and the discriminator cannot complain about it, yeah? Because the job of the discriminator is not to tell if the output is creative or if the output is real or otherwise, yeah? It's mostly the job of the discriminator is to look at the image and say if that image is real or it's fake, yeah? That's the only job of the discriminator. So in this instance, then, you end up with this kind of problem where the network is not being creative anymore, yeah? Because it keeps on spewing the same number without even trying, in a way, to create new numbers. Yeah, so that's called mode collapse, yeah? So in order, in a way, to address that issue, you have this kind of network CycleGAN. And the assumption and the core, in a way, idea of CycleGAN is that if you translate a sentence from English to German, or if you have a network that is able to do that translation, then that network has to prove that it learned by translating the sentence from German back to English. And then that network still has to prove that it's able to look at the sentence in German, translate it into English, and from English back to German, yeah? And only then you can in a way, validate and say that that network actually learned something. Yeah. So this process, in a way, then really forces the generator to be creative, yeah, and to really learn exactly the underlying, in a way, structure, without, in a way, finding this kind of way of just spewing the same output all over again, and having then the discriminator not being able to complain about it, yeah, because the discriminator again is just classifying things, is not saying if something is creative or not. So in this instance, yeah, on the left side you have Pix2Pix mostly type of data set, and on the right side where you have unpair, that's mostly an input for CycleGAN. Yeah. So in the case of Pix2Pix, as you can see here, you have facades. So you have the input labels, and those labels, like each color represents an architectural element that was identified by a human. Yeah. You, as a human, you went in and you draw those and you identify this is a window, this is a column, this is a door, and so on. Yeah. And you start to annotate, in a way, those architectural elements with different colors. Yeah. So like that, the network looks at both those input and output, and it's able to learn, in a way, that relation between those two. Yeah. And then later, once the network learned, you can input completely new images like this of labels, and the network will be able to generate completely new facades, let's say. Yeah. In the case of a CycleGAN, mostly what you have a collection of some images and a collection of other images. Yeah. And then in this sense, you're not pairing, you're not saying for this image, you have to translate like this to this image. Yeah. Like we do it here. Yeah. Here we are saying for this input, you have to translate that in this way. Yeah. Here we are not saying that. Here we are just saying you have this set of data and you have this set of data. You look at those two and you have to try to figure out to learn between those two. So this is, for example, one example of CycleGAN, where it's looking at Rome and I think Venice. And you have this kind of translation of it. Yeah. Now, if you ask me, this is a very poor CycleGAN. I'm going to show you some networks that I worked on, and so I started on some networks. I started from an idea of a CycleGAN, and slowly I developed the network at a level where they cannot really, they don't come across as being a CycleGAN, because this one feels almost like you're just coloring, in a way. You're just coloring, in a way, this movie from here, which is not really that interesting. So yeah, so here then CycleGAN also addresses another problem that, again, it's a matter of computer vision. The researchers in computer vision, they ask these kind of questions, and they were trying to solve certain problems. Yeah, so they were looking at image-to-image translations. So they looked at Pix2Pix, for example. Yeah, so I give you a reference image, and I give you exactly how that image has to look like. For example, I'm giving you exactly a painting of Van Gogh like this, and then I'm going to give you also the pairing, exactly the same perspective from the real world. Yeah, and you ask the network to learn those. Yeah, but what's happening there? Imagine that it's extremely hard for us to develop those kind of data sets. Yeah, where if you want to create this kind of Van Gogh, in a way, interpretations, you have to look at the painting, Van Gogh painting, and then find exactly the same perspective in the real world and use that as an example to a Pix2Pix network. Yeah, so that's very problematic. But here then the researchers, a different problem that they were addressing is this of how you generate then those data sets. Yeah, so in this case, the CycleGAN doesn't require you this kind of pairing of data. Yeah, you don't need the real photograph with a perfect perspective to translate a Van Gogh painting, for example. Yeah, but instead allows you then to really have completely different, just have completely different sets with completely different perspectives, and just ask a network to actually learn the representation of two sets and ask it then to translate from one to another. Yeah. And this is what's happening. Is if you are thinking about it also, when you talk about translating from English to German, in many instances there is not a one-to-one translation. Yeah. And that translation doesn't happen like that. Yeah. Because there is a certain context to a certain sentence and certain words, and they have a completely different meaning in another language. So you cannot really translate it like that. Yeah. You have to look at the language overall, and then look at the other language overall, and then understand the underlying, in a way, structure of that language. And then you are able to create a translation. Yeah. So here the premise is the same. Yeah. So instead of really pairing images like that, like precise image to precise style or precise painting, you just give samples of one type and samples of the other type. And then you ask the network to understand those two samples or two collections of images and perform the translation. Yeah, so not going very in detail here, like when it comes to the network, but this is exactly the process. Yeah, if we go back to this kind of idea of how can I translate in a way the style of Sagrada, let's say, or the composition of Sagrada to a Gothic building. Yeah. So if you have just a network like a Pix2Pix network, very likely you might end up with that problem of mode collapse, where the network or the generator network is just outputting the same kind of image or the same interpretation of Sagrada, yeah, without, in a way, trying to be novel and to create completely new and all the time new output. Yeah. So here you have that process that I was describing when it comes to sentences from English to German to English. Yeah. So you have one network, that Sagrada to Gothic. So you perform that translation from Sagrada to Gothic, but then you have to prove that you're able to translate back from Gothic, you're able to translate back to Sagrada. Yeah. So in this way, then the network really proves that actually was able to learn. Yeah. And it's not, okay, so this is an example from Memo Acton, where he's using this kind of objects, like everyday life objects in a way, in combinations with images of ocean or fire and so on. Yeah. So in this case, in a CycleGAN, you see that mostly it's understanding the underlying composition and patterns of this left side video, and then translating that into samples of ocean and so on. Yeah, perhaps Neil already showed you this this video. So here, just imagine, yeah, that you want to perform this kind of translation. Yeah, let's say that you want to have an image like this, just an image of a hand and some wires, and you want to translate this one into something that looks like fire. Yeah, for you to do that in a paired manner, like a Pix2Pix manner, you'll have to generate this image, and then you'll have to generate the interpretation, and then you'll move on like the next frame, and you'll have to generate the interpretation for the next frame and so on. Yeah. So this problem is actually quite challenging then. Yeah. So this is where the CycleGAN then really shows a lot of potential, because here then it's enough for you just to input samples or frames, let's say, of this video, and then input references of fire or ocean. Yeah. And then the network is able to look at both in a way sets of or collections of images and understand their underlying, in a way, idea and composition, and then it's able to translate between the two of them. Yeah. Okay, so a few other applications. So here, I didn't want it to show that a lot of examples in architecture, because I don't think there are that many examples in architecture dealing with CycleGAN. But I'm going to show some of Copiambla work that we did there. Okay, so another problem then with this kind of network, so you have Pix2Pix that creates this kind of, you have two networks and you have a paired data where you tell specifically to a network, these are the labels and that's how you have to interpret it, yeah? This is the perspective and this is how you have to paint that perspective in a Van Gogh, let's say, style, yeah? So you tell it specifically like how to do it. But like I was saying, you know, that kind of approach could lead to this kind of mode collapse where the generator actually, it's very lazy and it's outputting the same interpretation instead of trying to improve more and more and more, yeah? And to give, or to be creative and give more interpretations. Then the second, that problem was addressed by CycleGAN, yeah, by proposing that kind of idea of multiple networks that you have to prove that you learned. You have to prove that you're able to learn from a real image to Van Gogh, and then from Van Gogh translate to real image, yeah, and then from Van Gogh to real image to Van Gogh, yeah. So that's in a way a process where you're trying to force a network to actually be creative. Now, a problem that you have with those two networks, Pix2Pix and CycleGAN, is that it's very hard to disentangle the features, yeah? When the network learns, in a way, the relation between different features, let's say we talk about the face, and the network learns those facial features, it's very hard to disentangle them, yeah? And to go in specifically and to say, I want to modify this specific feature that refers to eyes, for example, yeah? So that's a very, very hard thing to do in Pix2Pix, CycleGAN, yeah, and other networks out there. So what the StyleGAN brought to the table to solve, you know, that problem was this idea of progressive training, where the network starts learning at a very small resolution and then slowly starts to increase, yeah? So what that means is that it's almost like this kind of analogy, it's a bird, it's a plane, no, it's Superman, yeah? So it's almost like that kind of, you know, like levels of detection, something, yeah? So first you just look at something and you just roughly maybe see, oh, there is an object, yeah? You are able to identify that there is an object because of the contour of it, yeah? But then you zoom in a bit or you increase in a way your resolution and you realize, okay, that's an airplane. Okay, and then you increase it a little more and you realize, okay, it's an airplane that has red wings. And then it's a commercial airplane and so on, yeah? So you're increasing, let's say, the resolution of what you're perceiving, let's say, yeah? So here then the network, the StyleGAN network does a very similar thing, yeah? So first it learns only to identify the overall shape of something. And then slowly it increases in resolution and starts to learn more and more and more and more detailed features, yeah? So because of that reason, because of that way of training the network, you end up with more access, or you're able to control more the features, yeah? You're able to disentangle those features much easier than the other two networks, which is CycleGAN and Pix2Pix, yeah? So this is a very big, in a way, contribution of the StyleGAN, where you are able to really look at specific, in a way, levels of features and then control those specific levels, yeah? Now, the architecture of it, of course, is more complex than just the training, But I think for us, it's enough, in a way, to understand this aspect of progression training and see its potential from there, yeah? Because there are a lot of other, like, very technical aspects of how you process, in a way, the features and what kind of filters you have on the network and so on, that they are not the scope of this workshop at this moment. Okay, so this is StyleGAN 2. I don't know if it has sound, but let's see. But the StyleGAN 2, it's even much stronger, even more stronger than StyleGAN 1. And so here you see this aspect of features, yeah, just based on resolution. So I'm able to read in a way the shape of it. I see that there is something there, sort of object or something. Then I increase it a bit, and then I start to realize that there is an object, but there is also something else on top of it, yeah. And then slowly I start to recognize even more and even more, yeah. And I start to recognize different, more detailed features and so on. So these are, in a way, filters on the network. So you'll see some examples that I'm going to show with Sagrada Familia. They deal a lot with this kind of play of fine-tuning and creating new filters for the network to learn correctly certain architecture features. So here, once the network learned, you see that it can move from different styles at different levels, yeah, like facial, like the shape, the composition of the face, the pose, like orientation and so on, or other details and so on, yeah. Yeah, if you search for this online, like StyleGAN 2, you'll see, you find the entire video. Probably can look over it. To keep the workshop short, or the presentation short, I'll just skip a bit over, yeah. But you can really have access to the composition of and semantics of data set. I'm going to share my screen. Okay, are you able to see it?
Yes.
Okay, so what we are going to do first, we are going to go into the software folder, and I would like to first establish a connection, yeah, between Google Drive and your computer. So we are going to install Google File Stream. So if you go into software, you'll have Google File Stream set up. And for now, just download this one from your browser and then install that, yeah. So in my case, I already have it installed. So it's going to look slightly different than in my case, yeah. So for example, you see now my screen. So if I install it like this, I still have to wait for it to download. So we'll have to install a few like softwares. Okay, so in my case, I just double click on the installation file for the Google File Stream. So make sure you install that. And once you have it installed, just make sure you log in with your Google Drive credentials, yeah. In the end, you should be able to have here in the lower corner, Yeah, in my case, it's already installed. But in the end, you should have here in the lower corner, you should have a file stream like this, an icon, where you can, in a way, connect and synchronize your Google Drive like that. Yeah, so once you have it, you should be able to see something like this: Google Drive file stream in your computer, in your Explorer. Yeah.
Daniel, one of our other DDES students, Anna, in Australia, has just joined.
All right. If you share a email address, I can also invite.
Yeah. Anna, could you put an email address in the chat?
Yes, in the chat. So for Mac, it's asking if it's working just on Windows. I think you should be able, if you go online, you should be able to find also for Mac. Stream Mac. Yeah, so I'm going to share a link in the chat, and you can use this link to download for Mac in case that you are using a Mac.
Anna, just could you put your email address in the chat?
Sure.
Okay, so you should be able now to get access to the drive. Okay,
Anna,
so
if you could scroll up, Anna, and just go, and there's a link to a Google Google Drive, Google Docs.
okay, so once you have access to the Google Drive, just go into software and then just download the Google Drive file stream and then install this. Yeah. Once you have it installed, probably at the beginning, you have to go to start and then start it from here. Drive file stream. Yeah. And you open this and then it should be already connected. Yeah. But this way, then you should be able to have access to your Google Drive through your Explorer, yeah? So instead of going through the browser, you're going to go through your Explorer and you go inside your shared drive or drive like this, yeah? Where is it? This one. Yeah, so you see you can have access like this. So why we are going to do this is because we are going to use maybe data management tools, and we are going to augment data straight on the Google Drive. So like that, we don't have to always upload and download data from that drive, okay? So is it working for everyone? Can I have a hand raise or something just to see where everyone is?
Anna just skipped out of the chat, so she might have lost something, but she's back in again now.
Yeah, I'm back. I mean, can you hear me?
Yes.
Yeah.
When did you skip out, Anna?
Sorry?
When did you skip out? How much did you miss?
Well, I just logged in. So no, I have the drive. I have the drive in on Google Drive, and I'm downloading.
Okay.
Okay, so once you have this installed, yeah, the Google Drive, you just have to go to Start and then type in Drive file stream, and you open this app, yeah? You open this. Once you open it, you'll see that actually it's going to open an Explorer window. And like this, now you are going to be able to access your Google Drive from your computer without the need of a browser. Okay, so once you have that, we are going to go into shared drives. And in my case, it's over here, FIU Deep Learning Workshop 2021. And we have these three main folders: data management tools, neural networks, and software. And we are going to go into software. And first, we are going to start with Python. Then we are going to install Pip, Augmentor, Anaconda, and PyCharm. Okay, so first, let's go into Python. You just have to open Python. And now, depending now if you have a PC or Mac, you can choose which installer you want to use for that. Personally, I have PC, so I'm going to go inside here, PC. And then here, I'm going to right-click and say Run as admin. Yeah, so make sure you run this as admin. So in my case, I already have it installed. But in your case, at one point, it might ask you to add Python to the path or something like that, yeah? If you have that option, check that box, okay? Check the box and then just hit next. Is it working?
Yes.
All right. So can you raise your hand if you have it installed, just to see? So once you have Python installed, just raise your hand so that I know if I should wait or not.
I think the one person having problems is York.
Okay.
Yeah, I think, I'm fighting here with VPNs and stuff. I'm on the other side of the big firewall. You just go ahead and
so this is going to be recorded, so then you can watch it back maybe. Okay.
Yeah, either like this, or I need to first get a link to the Google Drive on an email, because my emails are emails that are not working. Or the emails that is working, that is like completely full. So need to quickly register a new email, something like that. And then I think I just follow the recording. I think it's okay. Yeah. And I listen in. I mean, seems not a big hack to install that software.
Yeah, just make sure you follow the order correctly. Okay.
Yeah.
All right, so if we have this installed, Python, next what we are going to do, we are going to install a Pip. So Python works with packages, and packages are libraries, are considered libraries in other languages. Like for example, in Java, that's a library. Here it's called a package. And the Pip, it's just a package manager in a way, yeah. A framework that allows you to install packages, for Python. Okay, so what we are going to do is we are going to go into Pip, and here you see you have how to install. So you just have a few instructions here, but I'm going to show you exactly how we do this, yeah? So first thing, the way we install this, we have to open our command prompt. So CMD, just open your, just click on Windows and then CMD, and you'll have command prompt. So before you open this, make sure you run it as admin. So right click and say run as admin. Then you're going to have this kind of window popping up, yeah, the command prompt window popping up. Okay, so once you do that, you see that what this points to here, it's saying C Windows System 32, yeah? So right now, for example, if I want to access something from Windows System 32, I will be able to do that, yeah? But for us, what we want to do is we want to read this getpip.py file, yeah? That's what we want to do. So then in order to do that, what we have to do is we have to change this path here. Instead of pointing to C Windows System 32, it has to point to the location where we have getpip.py, yeah? And the way we do that, we use a command called current directory. So we just type in CD, which stands for current directory, and then space. And afterwards, we just go over here and we copy this link, yeah? We copy this location of this folder, so copy, and then I'm going to paste that inside here into the command prompt, Control V, like that, yeah? And once I have that, I have to press enter. So make sure you have CD space and then the location on the drive of the pip folder, okay? So you press enter, and right now, probably you're going to get this or you are going to get nothing happening, yeah? So the reason for that is that we have to also specify the drive now. So I'm going to say G drive, yeah, G and columns, yeah, and then press enter. And now you see I'm in the correct folder, yeah. Okay, so once I'm in the correct folder, now I can try to install getpip.py or to access or load that file, getpip.py. Okay, so the way that we are going to do that, so that was the reason why we installed first Python, because now we use that Python that we just installed to read the getpip.py file. Okay, so I'm going to type in Python and then getpip.py. Okay, just like that. So Python space get-pip.py, exactly the name that you have here for this file, yeah? All right. And once you write or once you type that in, just press enter. And now you'll see you should have something like this happening, like collecting pip, like a bar or something like downloading, and so on, yeah? In my case, because I already had pip installed, probably it looks different than in your case. But in your case, it should look like this, yeah? It starts to load something, installing, collecting packages or messages like that, okay?
Daniel, I just sent you another email, the Gmail.
Is it on the chat?
It's on the chat, yeah.
Okay.
And you can send it to this one. Thank you.
Daniel,
right. Yes.
Can you also go over the pip thing again? I missed how you make it run as admin.
Okay, so this is the folder where we have pip, yeah? So the goal here is to read this file, yeah? We have to get to this file and we should be able to read it with Python. So for that, we'll have to go to CMD. So I'm just opening Windows, yeah? CMD, and then you should have command prompt app, yeah? So before you click on it, just right click, yeah? Right click, and then you should have an option, run as admin.
Yes, okay.
Okay. And once you do that, then you are in admin mode. Okay. And here then the next step will be, right now this one points to the folder of Windows System 32. And we have to set the location so that this CMD command prompt, it's pointing to the location where we have the getpip.py file. Yeah? So for that, we have to set the current directory, which is cd. Yeah? CD stands for current directory. And then we are going to copy the link where the folder is, yeah, this link from here, copy. And we are going to paste it here. So make sure that after CD, you have space, yeah? So CD space, and then the link towards the folder. Okay, and once you have that, just press enter.
Okay, got it.
All right. So now you see that the problem is that it's still pointing to C Windows System 32. So what you'll do now, you'll just type in C columns and then enter. And now you should be able to have it like this, yeah?
Column enter?
Yes. Just enter, yeah?
You said there was C and then column enter, or G?
In my case, it's G. G is only because my Google Drive, the letter of the drive is G, yeah? If on your computer it's a different letter, then you input that letter, yeah? So you see right now here above, I have G as a letter for the drive. So that's why I input here G. If you have a different letter, then use a different letter, the one that you have.
Okay, I see. Thank you.
Sorry, I didn't see that. Where is it? The letter?
So over here, for example, or if you go into your Explorer, yeah? In my Explorer, I have it, Google Drive file stream, I have it as G, yeah?
Gotcha.
And the reason for that is because I have other drives, yeah? In your case, maybe it's a different letter. Okay, so once you have it like this, we just have to type in Python get pip.py. Yeah, Python get -pip.py, and then you press enter. And once you press enter, you should see this kind of message collecting pip or something, or installing, and so on. Yeah.
So mine is not labeled as getpip.py. It's just getpip. Should I write it like that?
No, just write it with .py, yeah. Because what you have there, I think you're not showing the, in your computer, you're not showing the file extension. So if you go to view, for example, and you say file name extension, then you're going to have that too, yeah. You see?
Okay, I see. Because without the when I did type the py, it wasn't actually showing a command prompt when you hit enter.
Mm-hmm.
For some reason, it's telling me that Python was not found.
Did you add, when you install Python, did you add it to the path? There was an option when you're installing Python. There is an option, like a box that you can check to say add Python to path.
Okay, I'll do that again real quick.
Okay. Okay, so let's continue then. So you have pip. You should have this installation message like this, or even if it's different, that's fine, as long as you don't have an error. That's fine, yeah. Okay, so what I'm going to do now, I'm going to go to the next. I'm going to open the Augmenter, and here we have to install Augmenter, yeah. So after you have pip installed, now we are going to just go here into a command prompt, and we are going to type in pip space install and Augmenter, just like that, yeah. So pip space install space Augmenter. Okay, so you just type in pip space install space Augmenter, and then you press enter. And in my case, it's already installed, but in your case, it should show that it's installing Augmenter. Okay. All right. So once you have Augmenter installed, now we can continue, and we can go to software, and we should install now Anaconda. So if you go into the folder Anaconda, you go to PC or Mac, and then you just double click on it, and you should be able to install Anaconda. So during the installation of Anaconda, you're going to have, again, the option of add Anaconda to path. In this case, don't select that box, yeah? Just leave that box unchecked, okay? So in my case, I already have it installed, but I'm just going to go as far as I can go with it. And in my case, it's going to stop here because I already have Anaconda exactly in this location. Make sure that you have enough space on your C drive. It's preferred to have all this Python and Anaconda, PyCharm, all these things. It's preferred to have them installed on your C drive, not somewhere else. So make sure you have enough space on your C drive. Anaconda alone will require 3.1 gigs to install, yeah.
Daniel, I have a question. So Python and Anaconda are already installed in our own system, but we are installing the pip and augmentator in the shared drive.
No, so if you already have Anaconda and Python, that's fine. You can skip then the step. But what's happening when you install pip, where that it's installed, even if you read it from the Google Drive, it's going to install it here into your documents. And where is it? Let's see, C drive, users. So.
Oh, I see. You're actually installing it from the shared drive to your computer. Got it. Okay.
Yeah, it's going to be into your computer. Yeah.
Yeah. Thanks.
Okay. But I think you have Anaconda and Python from the workshop, no?
Yes, I do.
Okay, then that's fine, yeah.
I'm sorry, Daniel, there is a question on the chat. I'm getting a message when trying to use command Python get that Python is not internal or external command or file.
Okay, so you have to make sure when you install Python that you add it to the path, yeah? And what I would suggest is just go into your command, into your control panel now, if you have this error. Go into your control panel and then go into, where is it? Programs and features, and uninstall Python and also Python interpreter. So if you go down the list, you should uninstall both these ones, yeah? Python launcher and also Python 3.74, yeah. And only after you uninstall them, install again Python, the one that I share with you, and then make sure you add it to the path.
Hi, Daniel.
Hi.
I have a question. First off, thank you so much for this. Second, you said don't add the path to the Anaconda.
For Anaconda, yes.
Yeah, but then I don't know if I missed anything about the register Anaconda as my.
No, you don't have to, don't register. You don't have to create an account. You just close those.
Perfect, thank you.
You're welcome. All right, so if you have Anaconda installed, we can now continue and we can install PyCharm. And PyCharm, it's exactly what you see here. Yeah, this is PyCharm. It's a Python editor that is going to be used for us to deal with certain script, yeah, Python script. It's maybe much easier than to deal with it differently. Okay, so if you go into PyCharm now, you have the same two options, either PC or Mac, and just install PyCharm community, yeah? So these are all free softwares. So you don't have to register, you don't have to create any account. So again, in my case, again, I already have PyCharm installed. So it might be that you don't see certain steps on my screen. So again, in case that you have an option here, if it's asking you to add the path, do not add it to the path, yeah? In case that PyCharm asks you to do that.
If I already had that installed, should I uninstall it and redo
No,
it,
no.
or is
No, it's
okay?
fine. Okay, can I know status, hands up? Let's see. Are you still installing PyCharm or?
I'm like a little bit over halfway from installing Anaconda.
Okay.
Yeah, same here.
Okay, then I'm just going to wait a bit, yeah. So that everyone installs Anaconda.
In the meantime, I have a question.
Yes.
It might be a very simple question, but what would be the main difference between running a network here using Python like we're gonna do, or in contrast with Runaway ML, for example?
Okay, Runway ML, they already have, they're using their own servers to train, yeah. And in the end, you don't have access to the network. You just have a few parameters that you can work with in Runway ML. So the difference is that, yeah, you get more control over it. You're able to actually really control not only the data set, but also parameters like hyperparameters, resolutions, other kind of aspects, yeah. And now Runway ML, yeah, it's running on their server and it costs you money. While this one, if you run it on Google Colab, it's for free, yeah. So of course, also Google Colab, if you want to have the Google Colab Pro, which allows you to run four notebooks, Jupyter notebooks in parallel, or 4 sessions in parallel, then it's kind of worth it to pay $10 per month, yeah. And you can discontinue that anytime you want, yeah. So personally, I have Google Colab Pro. I have my own like deep learning in a way machine here. So it's actually better than Runway ML. Runway ML, it's good if you don't really know how to operate the networks like yourself, like to start the network, to build up the data set correctly. They have that process quite nicely streamed, but otherwise, yeah, I will not use it because it's costing a lot of money. Like for example, if you want to run a StyleGAN, and you want to create some interpolation like latent walk and stuff like that, it might cost you for 2 hours of training, might cost you $10 or something like that, which is quite a lot, you know. Yeah.
All right, thank you.
You're welcome. All right, so are we still waiting for Anaconda to install, or we are installing PyCharm now?
I just finished downloading Anaconda.
Okay.
And I already have PyCharm, so I'm not going to speak on that. I have to create an account with Anaconda though. Do I do that now?
No. No account. All right, so if we have PyCharm installed, what we are going to do, we are going to continue, and we are just going to Philippe, maybe you'll have to do the same thing like I suggest to others, like make sure you uninstall your Python and Python launcher and install it again. Make sure you add it to path, and then maybe also give a restart to your computer. Okay, and then you should be able to fix that issue. So the same also, Elena. Make sure you uninstall first, not only reinstall. Yeah, make sure you uninstall Python and also Python launcher, and then maybe right after you reinstall then Python, just restart your computer, and then probably it's going to work fine. Okay, so once we have this, now we are going to go into the data management tools, and we are going to start to install certain things, yeah, over here. So, but before we do that, I'm going to do something like this. I'm going to open, you'll see that here you have data management tools, you have Augmenter, you have scripts, install requirements.bat, and so on. Yeah, so I created a few batch files for you that can help you easily to manage, in a way, data set, yeah, without interacting necessarily with scripts, yeah. So if you open this by right-clicking, like right-click and then edit, in case that you have the same issue like I do here, it's saying Windows protected your PC, then just click on more info, yeah, and then just say run anyway. Yeah, so you should have a Word document like this, yeah, with this kind of information here. Okay, so the first thing that we will have to do here, we have to make sure that we are pointing to the correct location, of Anaconda on your computer, yeah? On my computer, it's in user, my user, and then Anaconda tree. So if you go into your computer, just go to your computer and then go to your C drive and then users and your user, yeah? And then inside that user, you should be able to find like this Anaconda tree. Yeah, so go inside that and copy this location. Just copy that location and you're going to paste it over here where you have set root.
Just a quick question. For the PyCharm, do I have to change anything, add launchers to the path?
No. So, okay. Okay, so we have this, yeah, install requirements. You have to add set root to your Anaconda tree location, yeah. In my case, it's under user, my user, and Anaconda tree. Okay. Now, another thing that we are going to do here, we are going to create or add an extra line here. But before we do that, what we want to do is in Python, you have something called an environment. So what you can do is you can create, for example, an environment where you install Python, let's say 2.7, and then you install a set of libraries there, yeah? And then you can create another set of another environment on which you install Python 3.7 and have a set of libraries, yeah? So in that way, you can have multiple versions of different libraries or packages without having a conflict, yeah, between them. Or you could have, in a way, certain packages or libraries installed, and in case that there is an issue created between them, then it's not destroying the entire setup of your computer, yeah? All right, so the way that we are going to set up an environment, we are going to use Anaconda, yeah, for that. So I'm going to go to Windows, and I'm going to type in Anaconda, and then I'm going to use this Anaconda prompt, yeah? So I just type in Anaconda, and you should see Anaconda prompt. So again, I'm going to run this as admin. So right click and then admin. And here, what I'm going to do is I'm going to start to create here in Anaconda an environment, yeah? So the way that we are going to create an environment is by typing in the following command. So conda space create _ name, and we are going to call this environment deep learning, just like that, yeah. So conda create _ name space deep learning, and then I'm going to press enter. Okay. So this command here is going to create an environment, yeah, and within that environment we are going to install the following the libraries that we have here, or the packages that we have here. Okay. Okay, so let's just press enter here. So in my case, I already have deep learning environment. Let me then create another one with a different name, yeah? So I'm going to say FIU deep learning. Yeah, so I'm going to create a new environment like that. So conda create a space _ name space FIU deep learning. Okay, press enter, and you'll see now that it's going to create an environment. So solving environment done, and now it's going to install certain packages that are required there. And just in a moment, you'll see that it's going to say that I can activate the environment. Okay, so here it's asking me to confirm, to proceed. Yes. And there you go, yeah. So now everything is done without any error. And it's saying that I can use conda activate to activate the environment, or conda deactivate to deactivate the environment. So the way I can activate the environment, I'm going to use that command, yeah? So here you see that over here, before C, you have base, yeah? So that's the base environment, yeah? The default environment Once you install Anaconda, that's the default environment. Now we are going to type in here conda activate FIU, in my case, deep learning, like that, yeah? And then press enter. And now you see that instead of having base in front of C, we have FIU, deep learning, yeah? That means that whatever commands I'm going to run here, whatever libraries I'm going to write in here are going to be installed within this environment. Okay. All right, so then here into the install requirements.bat file, we are going to add this part. I'm going to just create here another, and I'm going to say call conda install, call conda activate FIU deep learning. Okay. So like that, if I were to double click on this file, it's first going to find where Anaconda is. Once it's finding Anaconda, it's going to activate the correct environment where I want to install these libraries, yeah? Okay. So now I'm just going to save this. I'm going to say save, just like that. And now if I double click on this install requirements, you'll see that it's going to open an Anaconda window. And then it's going to start to install one by one these packages that are there. Yeah. So it's going to go first with this Manpo OpenCV. So it's going to install that one. Then it's going to go with FastAI, PyTorch, SciPy, and Pillow, and so on. Yeah. Am I moving too fast?
No.
All right, so warning, a new version of Conda exists. That's fine. You don't have to worry about that, about updating Conda. As long as you don't have errors, then it's fine. Yeah, it's just a warning there. Okay, so here you might be asked in a way to proceed. Yeah, you have to type in Y and then press enter. And then that's going to continue installing things.
Daniel, what is the advantages of doing this Conda thing, like having multiple environments? Could you give us some examples, like in what kind of cases you define different environments?
So for example, let's say that I have a script that I'm working with TensorFlow version 1.1, yeah? And let's say that those scripts that I developed, they work perfect, yeah? I have like other libraries like OpenCV or other image editing, in a way, libraries that work without any conflict with TensorFlow 1.1. Yeah, I have all of those in one environment. Yeah. So in case that I start to install other libraries, let's say I start to install TensorFlow 2.0 in the same environment, it might be that Tensor 2.0 is creating conflicts with the libraries that I have. Yeah.
I see.
And let's say that I need to use TensorFlow 2.0 because I have a new network that I want to develop, and TensorFlow 2.0 has a very interesting method that I want to use. Yeah. So then I'm going to create a new environment where I'm going to use just TensorFlow 2.0. Yeah. And like that, still retaining the other environment without any conflicts. Yeah.
I see.
You know. So this is something super cool, I think, for Python. Yeah. Because even like this, you'll see if you jump into Python and really go working a lot with it, there are a lot of libraries. Yeah. A lot of libraries that are open source, that are developed, by just people who wants to contribute, to the community. And then you'll have a lot of issues with compatibility. You'll have issues with, parts of the code are not updated correctly. So yeah, this part avoids in a way that headache. All right, so you should be able to have that now installed, yeah. And once it's done, you'll see that it's going to close. I think it's going to close by itself, yeah, this install requirements. All right, so if you already have also the install requirements done, then pretty much we are set up, yeah. And then next time we can just jump into working with neural networks. Okay, can we make sure that it's working for everyone? Let's see, do we have problems?
I'm having a bit of delay downloading, so I'll just follow the workshop, and once
Okay.
it's downloaded, I'll keep going.
Okay.
Yeah, me too. Anaconda's taking a little bit.
Yeah.
All right.
Where can we access the recording?
I don't know, it's Biana or Neil who has the recording. Who started the recording?
Right now, this is on a unlisted YouTube link. We'll share it with you. We just ask you not to share it publicly.
Okay.
Okay. And is there maybe could we maybe schedule if we not succeed prior to the next workshop? Could we maybe schedule a Q&A session if we encountering problems, or can we just shoot an email to you and we do it one by one? Or
I work very expensive, so I don't know. Per hour, I'm going to ask for a lot of money. Yeah, I don't know. Yeah, maybe if it's a I was joking, by the way. If it's something like that we can fix quite fast, yeah, just send me an email,
Yeah.
and I can try to troubleshoot. Yeah.
all right, and your email is in this Excel thingy?
No, I don't think so.
I just type it here in the chat. Okay, thank you.
All right. Yeah, so mostly the problems that you might have are at the beginning with Python. Yeah, if you don't have Python correctly installed, then you might have issues installing pip. If you have problem installing pip, you cannot install the other libraries, and so on. Yeah, but make sure you have Python installed. If you have issues with it, you either have to make sure that first you uninstall all Python and Python launcher, and then install it again and make sure you have add to path. Yeah, and then maybe also restart your computer and then see if that solves the issue. Yeah, otherwise it might be that you have other versions of Python that create some conflict somewhere. Okay, so those will be the things that, yeah, in case that you have that issue still there. All right. Okay, so I think we can conclude it for today then, if more or less we have this covered, yeah. And we are just going to continue next time. We are going to start right away with neural networks next time. We are also going to use perhaps some Grasshopper or other applications online to generate some data sets. So just make sure you have at least Grasshopper installed, yeah. Grasshopper, I mean Rhino.
Okay, yeah.
My apologies, I thought 2 people waiting. I'm sorry about that. Yeah.